So if they give you the derivative, then we can work backwards. What I want to do is I want to set it up like an integral, just because I want to remind you that when they give you the derivative, that's the same as if we said, let's take the integral of 6x squared dx. And I could even say, and again, I'm just kind of throwing some notation out here, if this is g prime of x, when I take the integral of this, what can I say that equals? G of x. And it's something as we work towards the AP exam, I want us to get better at, of labeling what we're doing as we do a problem, because oftentimes we just put an equal sign. I'm just as guilty of it. But when you're doing a free response problem, you really want to be specific on what your labels are saying. But this isn't so bad, right? I can integrate this, power rule, what would I do? So could I say I would get 6x cubed over 3? And again, it's fine if you go ahead and simplify it. I'm just kind of showing you the steps here. Eventually I'll stop showing so much work. Is that it? Plus c, right? And this is what we did on Friday last week. This is taking integrals. The difference is we're solving the equation now, which means they give us this information. They give us some point on the original function that we can use to actually figure out what c is. Remember when we did this last semester? The only difference is they're saying solve the differential equation now. So could I plug this in? This is my x, this is my y, right? And I can just solve this for c. That's my last step. So g of 0 equals -1, so I could say -1 equals 6 divided by 3 is 2 times 0 to the third plus c. And that's just -1, right? They don't always work out so nicely, but lots of times they give you 0. We call this an initial value problem because they give you what it is at 0, which is like the initial place that it starts. And could I write my final equation now for g of x? Don't forget to do that, just like back in the day when we were writing slope equations. Don't forget to go back. C is -1, so I'm going to say g of x equals 2x cubed minus 1. Super great thing about these, could you take the derivative of this and make sure that it equals the derivative over there that you started with? Yeah, so you can kind of check your work as you're doing this. That's not so bad, right? It's a good Monday morning calculus activity. Let's do another one. I don't know. That doesn't change till tomorrow. I did actually, but you weren't listening. But the next one. I don't know. 3 pounds, 17 inches. That's about the size of it as last week. 70 days. 10 weeks from today is my due date, kids. Haven't had another ultrasound. But yes, it's a boy. No one. I don't know. How about this one? Same idea. The directions are solve the differential equation, which means find the original function. Difference is they give you the second derivative, right? So how many times are you going to have to integrate? Twice, because you can integrate the second derivative, and again, I just want you to kind of label this as you go. If I take the integral of x squared, which is my second derivative, what could I say that's going to be equal to? F prime of x. And it's really important to label that. One, it helps you stay organized, and two, it helps the person that's reading it or grading it stay organized. So why don't I let you kind of work here and see where you can get. sure we all remember that. The plus c is super, super important, right? Integrating this x cubed over 3 plus c. You can't integrate again until you know what c is. Does that make sense to what I'm saying?
So you have to solve for c before you integrate again.
Yes, because it's important. Like, if c is 2, that's going to change than if c is 7, or if c is 0. Like, it matters. So this is why they tell you that f prime of 0 equals 6, because you can plug that in at this point, and then you can go from there. But I guess maybe you could wait till the end, but then you'd have 2 different c's in your problem, and I don't know. I don't think that's a good idea. But when you integrate it, you're putting a variable back with it, right? Because if you forgot the c altogether, then you're missing part of the problem. You could integrate c and say that it's just cx, but then you have to go back and remember which c is which, and I just think it's going to lead to silly errors. Right, so I got the first derivative to be x cubed over 3 plus 6. And then what most of you were jumping to, forgetting the c part, is to find the original function, we are going to integrate a second time of x cubed over 3 plus 6. And again, it's good habit here. You need to put this dx here. I know that we're not really using anything with it, but when you're writing an integral, if you don't put the dx there, then it's technically wrong. On the free response, if your job is to write an integral and you forget the dx, you're going to miss that point for that integral. What about this one? You get x to the 4th over 4, but it's already over 3, so do you agree that that's just over 12? Okay with me on that? Plus 6x plus c. If you wanted to just pull that out front, if you wanted to make that 1/3 x cubed, and then you could do 1/3 times x to the 4th over 4, so you could do that 12th there. Either way, you get a 12. Again, I picked really nice ones here when they give you 0, because it just means that if I plug in 3 here, this is going to be 0 plus c, so c equals 3. So I can say, if I know the second derivative is x squared, and the first derivative at 0 is 6, and the original function at 0 is 3, I know that the original function is x to the 4th over 12 plus 6x plus. And again, if you wanted to, you could check that and make sure that it works. Don't forget the c. That's really, if you forget the c, you're going to give the wrong answer. Questions about that? The last thing we're doing is stuff with velocity and acceleration. I took one of these out of the packet that I gave you, so you're welcome to kind of write down what it is, but you could also shorten this problem a little bit if you want to write the whole thing from it. Like, you probably could just write the velocity function. Like, if it was me, I would write number 83 per packet. But here's my velocity function. Kind of important that they tell us that t is greater than 0. They're also giving us some information, just like the problems that we just did, only now it's kind of written as a story problem. It says at time t equals 1, its position is x equals 4. If you want to shorten that up a little bit, you could say, I think we usually use s for position function. We could say at 1 second, the position is 4, or I guess they use x. So I'll use x. That's weird. X of 1 equals 4. And they want you to do two things. They want you to find the acceleration and the position functions for the particle. Because we know how to do derivatives and now we know how to do integrals, it's really important as we start getting into more application problems and story problems and AP type problems that you think about, what am I doing on this problem? If I'm finding this, am I going to be taking the integral, or am I going to be taking the derivative? And your mind kind of has to go back and forth between the rules of derivatives and the rules of integrals, and that's where it's really easy to go the wrong way. But let's just start with acceleration. If they give me the velocity and I want the acceleration, what could I do to find that? Yeah, if I take the derivative of the velocity function, does that give me the acceleration function? I don't need to integrate anything. I'm going the next step, right? And so that's kind of a thing that you have to start thinking about. Am I taking the derivative or am I taking the integral? So to find the acceleration, I'm just going to kind of show some work here. The acceleration equals the derivative of the velocity function. So I just need to take the derivative of that. So we could do the quotient rule here, right? I don't want to do the quotient rule. What else could I do? Could I bring that up and say that the velocity function is the same as t to the negative 1/2? Yes? And how do I take derivatives again? I gotta think, 'cause it's been a while. Bring it out front and subtract 1, right? So that would be negative 1/2 t to the negative 3/2. And again, it's not a multiple choice problem. Could you just leave it like that? You could. I feel like I should show you some simplification of it. I like to get rid of my negative exponents at least. Like I would probably write this as negative 1 over 2 times t to the 3/2, like just move it back to the bottom. But just to show you, because again, multiple choice, you want to match it up, that would also be the same as saying negative 1 over 2 times the square root of t to the 3rd. So that's the outside, that's the inside. All of those are okay. I wouldn't mark it wrong if you left it like that on this one. I just want you to start thinking about that. When we take our tests, most of our tests this semester, they're going to be AP style, which means half of it's going to be multiple choice, and you got to be able to match your answers up. But that would be my acceleration. I'm going to circle this one. What about the position function? If they give me the velocity, well, I also know the acceleration, but I don't really want to go 2 steps that way. If they give me the velocity, which way am I going to get the position function? Backwards, right? And going backwards is integration. Agree with me on that? So if they give you velocity and they ask you to find the original function, we know how to do that now, because it means just take the integral. Because if I took the integral of this, remember this is the derivative of the position function, that's going to be the position function. And also notice that's why they gave me this information. If they didn't tell me at time t equals 1 that its position is 4, we're going to have a c in this problem that we don't know what to do with. So to find the position function, we're going to have to integrate. And again, I'm going to use the same letters that they used. Since they're using x here, I could say that the original function x of t is going to equal the integral of the velocity function, which I'll just go ahead and say is t to the negative 1/2 dt. Notice I changed it from dx. Why? Because now we're using t. Whatever letter you're using, that's what you're using as your d whatever. By the end of this week, you'll know what that means a little bit more, what that dt or dx means. Little proof stuff. Go ahead and integrate that. Add 1, divide by that. Don't forget your c. See if you can plug in the initial value to solve for c. to the 1/2 divided by 1/2. And they tell me that its position is 4 at time t equals 1. So that means that this would be 4 when this is 1. And 1 to the 1/2 is just 1. So I actually had to do a little bit of work on this one, not too much. C equals 2. So, what do I have here? 2t to the 1/2 plus 2 would be that original function. So a lot of these problems today, they're kind of two parts, like they want you to go take the derivative and do the integral. But sometimes it's just one. And on the AP test, definitely, they're all mixed up. Sometimes you integrate, sometimes you take the derivative. And so we're going to start seeing those as we have to think about which one am I doing on these. Questions on that? That's all my notes today. Isn't that ridiculous? So this is still from that packet, and I believe this is the one that's actually stapled, and you have this page in there. Starting at number 42. You can kind of just circle them on there if you want on the packet. Most of them are what? You have graphs on there. Yeah. There are some graphs on there, which is probably why